Alright, so what's up my friend and welcome to this new video. So in this video I'm going to explain what is a process in C, like how we can create a new process, what is a process, how a process work in C. And in order to understand this deeply, we're going to implement a shell pipeline, a simple one using C language. So I didn't just want to explain what is a process and give some examples and in the video. No, I want to explain it in a practical way. So the thing that we are going to implement this shell pipeline. So as you can see, this shell pipeline contains a lot of things. So let's start from the beginning. First, as you can see, we have in file. So this file, it's going to have a text. So this text is going to be like an input for this command that's come after the file. So here we have the file and here we have the first command. Alright, so this first command is going to read from this file and to be executed. Alright, then here's the thing, like here's the funny thing, that this command, like the output of this command, is going to be passed to the other side, which is this part. So think of it like this is a two parts, like, or two sides. This is the first side and this is the second side, and the bridge between these two sides are these pipes. So later in this video I'm going to explain to you guys what is pipe, how you can create them, how they work, right? But now think of it like this is a pipe and it's a bridge between two sides. Alright, then when we pass the output of this command to the second side, it's going to be taken by this command as an input and it's going to be executed, and the output of this command is going to be redirected into this file. Alright, so that's it, and let's give it an example to see. So for example, I need to create a file, so nvim, for example, in file, for example, let's say hello abc, I don't know, sec fault, and here I don't know, hello, for example. Alright, so here we have two lines that contains the character a. Alright, so if we did this command, as you can see, we should have two in the out file, because first we are grouping the a, so we will get two lines. Then we have wc-l, so we will count how many line we get from the first command. So if we did cut out file, sorry, we will get 2. Alright, so this is like the concept of this video, and let's get started. First, what is a process? A process is just a running program. What? Just a running program like this, in this simple fucking way. A process is just a running program. So for example, we have this command which is man-top. So this man-top, it's a program that preview the running systems, like the threads, the processes that are actually live running and managed by the Linux kernel. Alright, so if we did top, we'll see all the running process in our system right now. And here, as you can see, we have the Audacity, like the program that I record my voice, OBS, and a lot of things, Chrome. Okay, so these all are running processes. Alright, and as you can see here, also top is a process. Alright, so first it was just a binary in the local bin, but when I call top, it's have been executed, so it's turned from just a file in my file system to a process that have an process ID and a lot of other information. So I know I need a proof. So for example, here I'm going to create a file called main.c. So nothing, I'm just going to do int main. So int main like this. For example, let's say while, and it's going to be an infinite while loop. Alright, everything is good. Let's continue. GCC main.c, we have a problem. I didn't add the semicolon. Alright, good. Now, just to know, this is just a useless file in my computer. This is just a binary file. It's not a process. But when the time I run this file is going to be a process. So just to prove to you this, guys, I'm going to run top right here, as you can see, or let's run top right here. Okay, and here I'm going to run my binary. So as you can see here, we have everything is clean. So when I run errors out, as you can see, we will have the errors out added to my list of running process in my Linux. All right, so as you can see, it became a process with its process ID, CPU usage, and a lot of things. All right, so like this is the thing. Process is just a running program. I know it's not that simple, but this is the idea that you can get in your mind like this, right? So that's it, and let's close all of this and let's see how we can create a process. And here it's come the funny part, which is this fork syscall. All right, so as you can see here in the description, a fork creates a new process by duplicating the calling process. Good. So the new process is referred as the child process, and the calling process is referred as the parent process. So let's try to draw this in order to understand it deeply. All right, so here, for example, as we can see, we have our running process. So here, for example, we have our main.c and it's been run. So here main.c, for example. Good, let's make it a little bit bigger. All right, good, like this. All right, good. So here we have our main.c. So by the time you are going like this, then you are executing some instructions. But the time you are like doing like this, like calling the fork function, this is what is going to happen. So first, it's going to split your program into two phases, or in a more technical way, is going to create a new process. So it will remain the first process. So here, as you can see, we will have our normal main.c, which is referred as the parent. So this will be called the parent process. And here we will have something called the child, because logically the parent should have a child and the child should have a parent logically. So here we call it the child process. All right, so like this, how we could create a process. So here we have the parent and here we have the child. So for example, here, just to understand, we have a normal process. When we arrive to the part when we call the fork function, it's going to split this process by two processes and it's going to create a new process called the child. Good. So let's see the child process. The child process and the parent process run in separate memory spaces. Good. So each one of these processes have its own memory space. So basically this will have its own memory space like this, and the parent also, it will have its own memory space, like its own stack, its own heap, its own data segment, its own text code, and everything. All right, so just keep this in mind. Let's continue. Then at the time of fork, both memory spaces have the same content. Good. So they have a separate memories, but they have the same contents. How? So for example, here, let's say we have a variable, like in our code, like in our main.c, before calling the fork function, we have, for example, a variable called int x, and its value is 1000, for example, 100, sorry. All right, and we had also a string that contain, for example, hello world, for example, like this. All right, so just to know, guys, that this is going to be copied. So let's do like this. So this is going to be copied right here also, and this is going to be copied also in the child process and in the parent process. So each one, it's going to change its own version. right? So this have its own version and this have its own version, but it was the same version at the first before calling the fork function. Good. So let's continue and say file mappings. All right, so the child process is an extract duplicate of the parent process except for the following points. So here you have some good points. The child has its own unique process ID. All right, so what is a process ID? It's just an ID that it's given to any process and it's unique to each process, right? So like it's a way to the kernel it can identify this is the process and this is its number, like. So, and this PID does not match the ID of any existing process group, so there is no like two same IDs, right? So just keep this in mind. So let's continue. Let's enough theory and let's go into practice and let's make a process. Let's create a new process, for example. So let's remove this. All right, so first I'm going to zoom in like this and I need to include for example the stdu like this .h, and also I need to include the unistd. So here we have unistd.h. Good. And here I'm going to create also, so I need to include the sys type for the PID-G type. So here we have types.h. Good. So here we have PID-G PID equal fork. Right, so it takes nothing. So here just to know, guys, it's going to return two returns value depend on each process. So in the child process it's going to return 0, but in the parent process it's going to return the process ID of the children, and we are going to see this. So here we are going to the if condition. So if the PID is equal to 0 means that we are running in the child process. So simply just I'm going to do a printf, for example here, hello from child process, like this. All right, and %d and new line and PID like this. All right, and here I'm going to do printf like this and hello from parent ID like this. All right, so %d and new line, and here I need to pass the PID. So logically here it should print 0, and here it should print the child PID, process ID. Alright, so if we did gcc main.c a.out, as you can see, hello from the parent ID is this number, and hello from the child, the ID is 0. So I hope you understand this. So this is like the basic structure. So this is like the basic structure of creating a new process using the fork syscall. Good. Now let's continue. So as we said, we have something else called the pipes. So I guess now the image like it's going to be clear right now. So imagine this is the parent process, like we are going to execute the first command in this phase in the parent process, and this part is going to be, for example, executed. So so imagine this part is going to be executed in the child process. So like in the scope or in the side of the child process, we are going to execute this part, like reading this file and executing this command, and we are going to pass the output of this command using the pipes to the other side, which is the like the side of the process of the parent, where it's going to execute this command and open this file and read to it. So I guess you start getting the image how it's going to be. Now what is pipes? All right, so pipes, imagine like as we know, the real pipes in the real world are something like this. Like we have here, for example, a line like this, and also let's make it, let's duplicate it, and also another line like this. All right, and we have something like this. Sorry, bro, I am suck at this. And bro, and we have something like this, and also something like this. All right, so this is the pipes in the real world. All right, so logically everything goes from here can go out from here, so it can be like this, and also everything goes from here, it can get out from here. All right, this is the pipes, and we bring this to the programming, and like we created something called the pipes. So the pipes in C is just a buffer in the kernel memory space. So it's like it's just a kernel buffer like this, right? So it's like this, it's just a kernel buffer with two file descriptors. All right, so like how we can create like the entry and the exit, we need to create something called an fd of two elements. All right, just a name fd, not something special. So when we create this fd of two elements, the fd of index 0 will be like the entry, so the fd of index 0 will be like the read, because we know the stdin is like where we read from. And also here we will have the fd of index 1 in the output, like the std out. All right, so when we pass this array to the pipe function, and we are going to see the description of the pipe syscall, so it's make like a connection between the fd of index 0 and the fd of index 1. So if anything you write from fd of index 0, you can read it from the fd of index 1. And also the same thing, everything you pass it to the fd of index 1, you can read it from the fd of index 0. So it's like this, so like it's from this way, and also it can be from this way. I know the theory is like this, it's boring, but let's read just the manual and we are going to do some examples. So man pipe, all right, so here we have pipe, and description is like this: pipe creates a pipe and a unidirectional data channel that can be used for inter-process communication. Like it can be used between two processes to make a connection between them, or a communication between them, right? So the array pipe fd is used to return two file descriptors referring to the ends of the pipe. So pipe fd of index 0 refers to the read end of the pipe, and pipe fd of index 1 refers to the write end of the pipe. So the data reaching to the right end of the pipe is buffered by the kernel until it's read from the read end of the pipe. So everything I said in the explanation was just reset, or they said it right here. All right, so you can pass data from fd of index 0 and you can get it from the fd of index 1, and the same thing like in the opposite way. All right, so I am going to stop blah blah. So I know guys, I'm going to stop and let's give it an example. So let's say clear like this, nv main.c, let's make it like this. All right, let's remove all this. So let's do int pipe fd of two elements, then we are going to do pipe our function, and we are going to pass with the pipe fd like this, our array. All right, then we are going to write to the fd of index 1. So we are going to write to the std out, and we need to read from the std in, right, from the index 0. So here we are going to make, for example, hello world like this, and for example just 11 bytes like this. Now we need to read from fd of index 0 and print. So size dash t and bytes equal read, and fd of index 0, and here our buffer. So I need to create a buffer, so buffer like this, char pointer, no pointer, just buffer of 20 elements like this. Alright, buffer, and I'm going to need 11 elements like this. And let's print f our buffer. So printf %s and a new line and the buffer like this. Alright, let's see. So gcc main.c out, yep, pipe fd, sorry, not just fd, pipe fd, and here also pipe fd. Good. As we can see here, we have hello world. So the thing here that we passed like this string to the pipe of index 1, so it's stored in the kernel buffer. Then we read from the kernel buffer using the pipe fd of index 0. It's like the real world when we write from the index from the std in and we write to the std out like this, right? So this is how the pipes work. So now we are done with the pipes. Alright, so now I guess we are ready to go to implement the shell pipelines. Alright, so let's remove this and let's remove all the files, yes, and let's get started. Alright, so just to know guys that I'm not going to my program would not expect the input to be like this, but it's going to be like this. For example, dot slash, for example, let's say sh pipe, for example, will be like this, like the sh pipe, like pipe, the name of my binary output file, and the file, for example the in file, the first command, for example the cmd1. Then I don't need here the user to enter this pipe. I just going to expect that here there is a pipe, right? Then here we will have the cmd2, right? Then here we will have the out file. So the argv of index 1 will contain the in file, of index 2 will contain the cmd1, the of index 3 will contain the cmd2, and of index 4 will contain the out file. So that's it, and let's get started. So here I'm going to create my main.c, and I need to include let's say sh pipe dot h like this, right? And here we will have our int main like this, to take int jc sharp pointer av, and we need also the environment variables, right? envp, alright, like this, and a simple printf hello world like this, sorry, like this, hello world, bruh. Good. And let's create our sh pipe dot h like this, and let's include our important header files. So here we have the std.h, the unistd.h, include also, let's say, sys/types.h, include also sys/state.h, include stdlib, and also are going to include string.h. I guess I need this also. And what else? Yep, include fc and gl.h. What else I can remember? I guess that's it. I don't know, but let's say, right? Then here I need but before that I need if forgot and if pipe sh pipe define sh pipe, and here we have our endif and if, right. So I need also a make file. So here we have make file like this. So I need my sources C files. So here sources. First we have main.c, and here the output file, it's going to be in this case pipe, let's say sh, just say output for example. Right, then output, then here my first target all gc-g, and the sources dash o output like this, output, and here clean rm dash force the output. Alright, good. Now let's do make. Good. No, good. Let's continue. So first I need an if condition. So as we said, I expect like the input to be something like this, like let's say the usage should be like this, like slash output in file cmd1 sorry, and here we have cmd2, and here the out file. Alright, so first I'm going to do an if condition. So if ac equal 5, which is good, else if it's not equal 5 arguments, then I'm going to print the usage. So here printf, and here I'm going to print this usage right here. So here is the usage that you can use, and here I need just to switch this like this, like this, like this. Right, that's it, and return 1. So let's do make. Yep, I need here the semicolon make. Great, let's continue. So first we need to create some variables. So for example, we need our int pipe ft 2 elements, pid dash g, pid. We need also, I guess, we need the size g bytes for the buffer. And let's start. First I need to create the pipes. So first we need to create the pipe. Alright, so it's going to be something like this, like pipe as we said, and the pipe ft. Alright, and here we need if condition, so we need to check if it fails or not. Alright, so if return, let's say if less than 0, then we are going to use the p error. Alright, sorry, like this. For example, let's say pipe. Alright, like this, and return 1. Then what we need to create, we need to create a new process as we said. So it's going to be 2 processes. The first process is going to execute this part, and the second process is going to execute this part like this. So if pid equal fork, no, it's not like this, it will be like this. So pid will equal this fork, and if pid is pid less than 0, then p error also fork and return 0. Alright, and here let's say comment creating a new process. Then here we are going to do a check. So here we have if PID equals 0. Let's say command check if like check if the process is the child process, like this. Alright, and here we have the else, where we will have our parent process. Alright, good. So I guess now I'm going to start the parsing. So first we need to open this file, so I guess it needs to be done before the fork. So I guess here I should open the file when I will check that the argument counter is equal to 5. Alright, so here I'm going to make a file descriptor, so int ft equal to 0, for example, and here I need also the size, so fd equal the open, and here the av of index1, the name of the file, then o read only, and o write only. Okay, and here is 0. Then we are going to check if fd is less than 0. Okay, so if fd is less than 0, then p error, like this. So p error open like this. Alright, and return -1, for example. Good. Then what we can do, then we need also check if this file a directory or not. Alright, so I need to call the state function, so I need here a struct, so struct state st. Alright, and here I'm going to call, let's say, comment here and the comment here, opening the file, the in file. Alright, then here checking if the in file is a directory. Right, so here we are going to do state, and this function, it takes like first the path, so av of index1, then it takes the address or the pointer to this struct, so address of st. Right, then we are going to check using the s is directory macro. Right, so we are going to do if is s is their directory, like the st dot element st mode. Alright, then if yes, printf %s, this is a directory, like this. Alright, then return -1. Alright, good. Now we have we parsed our file, so let's do make. So let's do make, and let's run. First, everything's good. For example, the name of the file is wrong, then it will show us an error. For example, let's create a directory, for example, like this. Then I'm going to insert my directory right here, so there, and there, this is a directory. Right, so first of all, everything's good. Then now what we need to do, now we are going to use a function called dup2. so this cmd1 need an input to read from. Alright, so I need to make this open file descriptor that point to this file object, and I'm going to make it like make this cmd1 read from this file using the dup2. So let's read the manual of this function. So here we have man dup2. As we can see here we have three versions. We are just going to use the dup and the dup2. So the dup is a system call allocates a new file descriptor that refers to the same open file descriptor as the descriptor old fd. So in simple term, the dup, it takes the old fd and it creates a new one that points where this old fd points to. Right, So this is just the dup, and the dup2 do the same thing but in other specific way. So we give it a two file descriptor, the new fd and the old fd, and what it do, the dup system call performs the same task as dup, but instead of using the lowest numbered unused file descriptor, it uses the file descriptor number specified a new fd. In other words, the file descriptor new fd is adjusted so that it now refers to the same open file descriptor as old fd. So in simple term, like this dup2, it makes the new fd point whatever or wherever the old fd point to. So for example, if the old fd point it's a file descriptor of a file, then this new fd will point to the same file. All right, so this is what we are going to do. We are going to make the stdin point to this to this file. So what we are going to do, we need to do like this. So here I need to let's make a comment making the stdin like refers to the open the fd of the in file, like this. So fd of the in file. So just we are going to do dup2, and here we have the fd, and here we have the stdin, the file descriptor, zero file descriptor there, like the read file descriptor. All right, then what we need to do, then we need to make the std out also point to the fd of index 1, like the output, like the right end in this pipe, because we need to pass, because we don't need to show the output in the terminal. No, we need to pass the output to the other side using pipes. So we're going to use the same function like here. So here we have making the stdin, making the std out refers to the fd of index 1 pipe. All right, let's say here right pipe, right end. All right, so dup2, here we have fd of index 1, and here the file descriptor 1, which is std out. All right, and here I'm just going to close, and here I'm just going to close the fd of index pipe fd, sorry, not fd, pipe fd of index 0, and here, sorry, the pipe fd. All right, good. So now everything is good. Now we just need to execute this command using Execve. So let's see this Execve like this. So Execve execute the program referred to by the path. So Execve takes three parameters. So Execve takes three parameters: the path, the argv, and the envp, the environment variables. So this calls the program that is currently being run by the calling process to be replaced with a new program with newly initialized stack and heap and blah blah blah. Alright, so the thing is that the path here is going to be executed by Execve, and it's going to replace the whole program or the whole process by this process that's Execve executed. All right, so it's like this. We're going just to pass to it the command, and it's going to execute it. So but before, as we can see, sorry, let's return to the manual. It takes the path. So first we need to find the path of this executable. So we need to create the path like /user/bin/ the command, for example ls, like this. Then we need the argv, the argument of this command, like ls-l. So it's going to be like this. So for example, here we have for example the command ls-l, for example, yep, like this. So what we need to do, we need to do a tokenization. So we need to parse this command and take this argument by itself and take this argument by itself, and we need to return this in a 2D array. So we need to return it in this array like this of pointers, where here we have ls and here dash l and here the null pointer. So it's going to be like this, like ls, and here we will have sorry bro, come on, dash bro dash l, and here we will have the null. So this is the form that this Execve wants. Alright, so for example, this is the command that we are going to get from the terminal. We need to parse it and make it as a tokens. Alright, so we need to create a function called ftsplit, for example. Alright, so nvm main.c, and here I need to make like this. So I need to create a variable. So here I'm going to create char pointer cmd, right, and here char pointer path, like this. Let's get out from here. Alright, and that's it. And here let's say I don't know, creation, like let's say what I need. First I need to make the command in a 2D list, in a 2D array. So let's say splitting the cmd into a 2D array. So cmd equal ftsplit, and here I'm going to pass the AV of index 2, and here the separator, right? So for example, here the separator is going to be space, because as we know, for example, the command is going to be like this. For example, let's say ls dash l, it is going to be a space between them. So we need a separator to know like how we can split these words. All right, so I need to create a file, nvm utils.c, so nvm utils.c, like this, and I'm going to include my header file, which is sh pipe.h, right, and I'm going to include my function. So char is going to return like an array of pointers. So here let's say ft split. Alright, here it takes the arguments. So here char pointer is cr, and here char separator. Alright, so first of all let's just print if the string %s and str. Alright, then I need to add this I guess into my header file. So I'm going to do cat utils.c, and I need to add this in my header file. Okay, alright, then we can do make. Alright, so we have a lot of problems in the main.c. First of all, I need just to add some semicolon, right here, and also right here. So make, yep, we need to add this file, which is the utils.c, into my make file. So here we have utils.c, like this. Good. Then here we need to do make and run. Yep, sorry. In file, and for example here we have ls dash, for example, dash l. Alright, so why it didn't print nothing? So let's go again to the main.c. Alright, so first of all we get inside the PID of 0, like the process ID, child process ID. then we close the pipe fd of index 0. Then here the dup2, we make the acdn point to where this file descriptor point to, and this is the problem. Here we make the std out point to pipe fd, so like after calling is split, the std out cannot print to the terminal. So what we need to do, we need to make like a backup. Alright, so I'm going to create a variable here, so int saved std out, like this for example. Alright, and I'm going to do saved std out equal dup and one, the file descriptor 1, and what I need to do here, so like for testing my functions, I'm going just to do just the normal state of std out just for tests. So here I'm going to make dup2 make the file descriptor 1 point to the saved std out. Alright, then we can see in the terminal like this. Alright, so now let's go ahead to our utils.c. So let's start. First let's remove this all spaces. First I need a variable int I equal to 0, int g equal to 0, int len, alright, like this, equal to 0, and I'm going to start by first counting how many words I have. Alright, so let's take an example right here. So for example, this is our command cmd equal like this, for example, ls-l. First I need to count how many words in order to allocate, like to know how many pointers in this array that I'm going to allocate. Alright, so here I'm going to do int let's say count, word count, like this, equal to 0. It will equal what? Equal to function like this, count word, and it takes the str, for example. Alright, so I'm going to go up here and declare this function, so int count word, like this. So we check char pointer str, like this. It have a variable, so int count equal to 0. Then I guess also I need the int I that equal to 0 and flag variable to indicate that like we are inside the word or outside the word. Right, so here while str of index I does not equal to null terminator I plus plus. Alright, so if the str of index I does not equal space, alright, then just we are going to do I plus plus, and that's it, I guess. Just I plus plus and flag will equal to 1. Alright, then here else if str of index I, let's make a space, is equal to the space and the flag is equal to 1. So here we need to do count plus plus, like we need to count a word, so count plus plus and I plus plus. No, that's it, I guess. And here continue, I guess. Or you know what, just here I plus plus, and let's remove this I plus plus, and here else just I plus plus. Alright, then here we need to return the count like this. So here I'm going to print the count, so printf %d new line and count make. Alright, L value and yep, I need 2 equals like this. Good. Y1. Okay, so here the flag. Alright, so I just forget if there is no space here. So if there is no space here, it will not count this word. So I just here need to add after the while loop and add an if condition. If the flag is equal to 1, then just do please count plus again to count the last word that have no like space after it. Alright, so if we did make again and run, everything's good. We count how many words we have in this command. So let's continue. Now we just need to count how many characters in each word to allocate space for it. Alright, so what we are going to do, the same thing, a while loop here, while str of index I does not equal the null terminator like this, or it's going to be automatically, and here I plus plus. Okay, good. Then here if the same thing, if str of index I does not equal the separator. Now we have the separator. Then I'm going to do I plus plus, len plus plus, and flag will equal to 1. So here I need the flag variable int flag equal to 1 like this, and then I'm going to do continue. Alright, continue like this. Then else if it's equal to separator, then else if str of index I is equal to separator and the flag is equal to 1. Alright, so before diving into this if condition, I need to allocate or to create a pointer to pointer variable like this, result, and I need to allocate memory for it. So malloc, and I'm going to allocate like the count word, so count plus 1 for the null, and I'm going to check if the result is null or not. Alright, and if yes, we're going to return null like this. Alright, then here I need now I have like I am exactly on the separator, so I need to go back and calculate the length like of this word. It's actually calculated using len plus plus, but I need the start index like to start copying from. So here int start index equals 0. Alright, so here start index equal I minus len. Alright, then what I need also, then result of index g, like index 0, is going to equal to malloc the len plus 1, and here we're going to start. So we're going to set another while loop. So while what. Alright, here we have the start index and here we have the len. Okay, so while the len is bigger than 0 or equal to 0, or let's just say bigger than 0, then the result of index g of index k, for example, let's add another variable called k, int k equal to 0. Right, like this, of k is equal to the str of start index. Then here we have k plus plus and start index plus plus and len minus minus. Alright, then I'm going to print, then I need to add here result of index g of index k equal to null terminator. Then I could print this result, printf %s new line, and the result of index G, like this. And here in the else if condition there's nothing like this. Alright, good. Then here I need to make the len equal to 0, so the len should equal to 0 again. Make. Alright, there is a problem. Yep, we need equal here. ls. Yep, the same thing. We need to add another if condition here after the loop end, and if the flag equal to 1 again, if the flag equal to 1, then we need to do the same thing right here. Then we need to, alright, I guess the same thing, it's going to be copied right here. Sorry. Alright. Okay, let's do make. What? Why? So here we continue I++ printf, and here start index. You know what? I'm going to call the gdb. So gdb break a domain lay n run in file ls -l cmd2 out file. Good, let's make it a little bit bigger like this. Alright, here I need refresh. Here I need set follow fork mode child, like to follow the child process. Alright, I need to do it in the beginning, I guess. Let's do it again. Know what, let's exit gdb again, break a domain lay n run in file ls-l cmd2 out file set follow fork mode child. Good. Now let's go inside. Let's see how many words we have. We have 2 words. Good. Now we are allocating for the first word. Refresh. Let's continue here like this. Print I. Print len 2. Good. Print the start index. Print str of start index dash. Good, everything is good. Print k. Here's the problem, the k should equal to 0, I guess. Yep. Alright. So let's make again this. Let's add here after the while loop finish, the k will equal to 0. Good, but where's the full command? Oh, okay, like right here. Okay, right here, like this. So make good. Everything's good. Now we have a 2D array that contain the command and its arguments. Then here in the end, just we are going to do return like the final pointer should equal to null. So result of index g equal to what? Equal to null, and please return this result. Good. What? Alright, so let's remove this printf right here, and also this, and let's add semicolon right here. Here let's do make good. Let's go back to our main.c. So now we have the command. Now what we need the path. Alright, so here we'll say getting the path. Alright. So here what we need to do, we need to do the path equal to get path. Okay, and this get path need the first command, like the name of the command, and that's it. Alright, so what we need to do, we have a function called access. So this function checks whether the calling process can access the file path. So we need to check is this file or this command is actually in the local user bin or not. Alright, so what we need to do, we need to pass also to it the environment variable. So we are going to go inside this environment variables and look for the path and run the command like on the access function on each path and check if this command exists or not. So we are need to pass so we need also to pass the environment variables, so envp, and let's create this function. So in the utils.c, let's go bottom here, the bottom. We have what you need to do, char pointer, just one pointer, and get path like this. Checks path, check the command, and checks the environment variables. Alright, so let's do a simple loop on this environment variables and print them to see. Okay, so like this. NVP of index I and I plus plus, and printf %s new line and NVP of index I. Alright, now let's add this function to the header file. Like this. So char pointer get path, and it takes the char pointer cmd command and char pointer envp. Alright, utils.c, yep. Alright, so we have a problem, I guess. Get path. Alright, so let's see nvim main.c char path equal get path. Right, good. Let's see nvim utils.c. we have here char pointer get path. Let's copy it, cut utils.c, and let's copy it like this, and let's go to our header file like this. Alright, Yep, char pointer cmd here, pointer the utils.c. this is a pointer, guys. So here a pointer. Now everything's good. As you can see, we have, so as you can see here, we have my all environment variables. Alright, so it's like this. We are going to look for these paths and check each time. We are going to split by this comma, by this 2 points, and each time like check, like do this and add slash here and the command and seek and check using the access function if like this file exit in this path or not, and also check for this and for this and all of these paths until we find a one path, then can run this command. So that's it. Let's continue. So nvim utils.c, and I guess, yep, that's it. I guess first what we need to do, I'm going to call char paths. I'm going to call ft split like this, split. I'm going to pass the nvp and what, and I'm going, no bruh, so what we need to do right here, okay, yep, I need to do a while loop. Alright, so I'm going to create the char pointer paths, and here I'm going to do a while loop. So while envp of index I does not equal the null I plus plus, and here what I need to do, I need each time I'm going to make something like this, like, right, so no the wait what alright, look guys, first I need to look for the path environment variable first. So I need to do an if condition. So if strncmp, okay, is the nvp of index I is equal to what, to the, let's say, path equal. Alright, if like, just so I'm going to compare the 5 first characters. If it's yes, please just printf for me, printf %s like this, new line, and nvp of index I, and break. Good. Now what we need to do, we need to put, alright, so what we need to do, alright, alright. So I guess the thing is that I'm going to make a pointer called start will equal to null, and here we have int len, a variable called len. Alright, then here what I need to do, here I'm going to do a while loop. So while the nvp of index I doesn't equal to len, no, I don't need the I of index g, so I need another variable g plus plus int g equal to 0. Right, so if envp of index I of index g is equal to equal, then please make the star point to this place, which is the envp of index I of index g, and let me print this start. Printf percentage s new line, or you know what, let's just do break right here, and out of this all this shit I'm going to make a printf. So printf percentage s new line and the start. Alright, you have some problems in the syntax, just like this. Alright, make also here blah 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 blah. Alright, something like this. Good. Now I just need to do +1 to escape or to move forward after the equal. So here just I need to do +1, so make like this. Now we need to pass all this start to ft split. So here the path will equal the start, the ft split of start, and the separator is going to be what? Is going to be this. Then I equal to 0, then while path of index I does not equal the null terminator I plus plus, printf percentage s new line path of no I guess s, and here also s, and here also s of index I, and make. Yep, I need here also something where yep, I need null terminator. Alright, why paths of index I? What is the problem? Yep, doesn't equal null. What? Let's do GDB. I'm going to do pmain lay n run in file and ls dash no not here, enter like this. Alright, you know what, let's do it again. Let's add here just a break. Break at the main. Bro, come on. In file, set follow fork mode child, and let's continue. Yes. Alright, let's see here. As you can see, how to start is good. Good. Break. Now let's go inside the split. Here we have 2D. Okay, everything is good. Alright, so print str, print separator. Good. Alright, let's continue. Print the str of start index. Alright, good. Alright, let's print the result of index 0. You see? Alright, everything is good. Why it doesn't get printed? Why the paths of index r does not equal to null? Printf. What's going on? Let's do again this while loop. Well, you know what, let's just printf %s null. Why? Why it's null? Alright, let's do GDB again. I guess there is a problem. Lay in, run in file, set bruh, come on, escape it. Run in file, ls-l same d2 out file. Yep, again. Alright, let's see. Alright, let's go to split. Alright, everything is good. So print result of index G. Everything is good. Okay. Print is star of index I. Okay. Let's continue. Opt. So first we had this, so print result of I minus 1. Print result of G minus 1. Bruh. What? Bro, I don't have G++. What a fucking stupid problem. Where is G++, bro? Where is G++? Here also I need to do G++. Make what? G++. Not. Let's do a while loop. Good, but what is this garbage? Should he be break at the main, lay in, run in file, assembly to out file. Yes, set follow fork mode child. Alright, let's see what's going on here. Alright, so print G. Good. Alright, so print result of index G like this. Alright, good. G plus plus and K equal to 0. Good. Nice. Print result of index G. Good. So what is the problem? What is the problem, guys? Do we have some printf or something like this? So here we have G. Alright, G plus plus. Why? Where this data came from? So here, guys, I noticed that there's a problem. Here the flag it's never like got reset to 0. So I just forget here to add the flag equal to 0 when we allocate a new word. Alright, so if we did make again and run, oh god, still the problem. But why I allocate? I guess here also I need to do it. But where did this come from? I don't know. Alright, so here also I need to do it. But here I guess no. Let's do it. Flag. I don't know where's the problem, guys. But in this split we have the problem. Guys, I see the code multiple times, but I don't know where's the problem, so I'm going to, I don't know. In file ls-l set Alright, let's see. Everything is good. Okay, so print result of index is 0, print result of index 1, good. Let's continue. Print result of index 2, good. Print result of index 3, everything is good. Okay, print result of index 4, good. Print result of index 5 also is good. Print result of index 6 also is. I don't know what is the problem, guys. How many count I have? What? What? Alright, so I guess this is the problem. I guess this is the problem. Yup. So I didn't allocate enough memory for this, because the count is just count just 1, but I need, like, the separator will not be always space, it can be like 2 points. So I need to modify the count word that it will take also a separator, so char separator also, and this is going to be replaced with separator, and this with separator, and here it's going to take the separator, and I hope it's work. Bruh, I don't understand, really. I don't understand what is the problem. What? Two 13. Where this 2 came from? What? What the fuck? How is this 213? Oh, yep, 2 for the command and 13. Like, alright, good. And now everything is good. Alright. So, sorry, let's continue. Alright, now we have the right amount of words. I really don't know where's the problem, guys. So, guys, I don't really know what's the problem. Here we solve the problem of the count words, so it returns the actual count depend on the separator. Here we are having pointer to a pointer result. Here we are allocating count. Yeah, in case I need to do the size, like the size of the pointer. So the size for sorry. So yeah, in case I am do size of char pointer, so I'm experimenting if it's going to work or not. Let's do make. Alright, finally. That was the fucking problem, guys. Alright, so let's continue guys, let's continue. Now what we need to do, we need to loop on all these paths. Alright, and what we are going to do, we are going to call the access function. So if we did man access, as we can see here, it takes the path and the int mode. So the mode are just some macros, as you can see. Where is the modes? Alright, we have here if OK just for the existence of the file. So this is the mode that we want. So we are going to do something like this, clear and vim utils.c, and let's go down here. Alright, and let's do access. Alright, it's called let's add the variable here, int return access equal to 0. Good. Then here I'm going to do return access equal access of the path of index I. Alright, good. Or wait. First I need to create the path. Alright, so here I need to do something like this, like I will have here a char pointer path, then this path will equal a function, for example, equal called ftjoin like this. It will take the paths of index I and the cmd. So let's create this function up here, char pointer ftjoin takes char path and here char pointer cmd. Alright, first I need the len. So alright, so int path equal len of path and int cmd len equal strlen of cmd. Good. And here alright, then here I need int I equal to 0, int g equal to 0, then here char pointer result equal to null, or just like this. Then this result will equal malloc of path len cmd len no plus. Let's continue. Alright, sorry. As we said, we have here path len plus cmd len plus true, null terminator and the slash. Alright, so let's do while path does not equal the null terminator, and here we have I plus plus. Good. then here the result of index G will equal the path of index I plus plus and G plus plus. Then when this while loop will end, then we need to copy also the command while cmd of index I does not equal the null terminator I plus plus. Alright, I should equal to 0 again, like this. Then result of index G will equal cmd of index I and G plus plus. Alright, then here in the end we'll do result of G equal this slash, no, I guess slash, or I guess no, I don't know, I guess I should do it right here, or you know what, I guess there's no need, because for example you have let's say echo. So for example here it will check, yep, we need to add a slash. So I'm going to add it right here. So result of G plus plus equal slash, then result of G equal the null terminator, then return result, and we are going to print the path. Percentage is the path. Alright, we have some problems. Let's see. Alright, like this here. Let's see what else. Yep, in the line 193. Okay, yep. Just let's do a new line. Let's add a new line right here. Good, now we have the path slash ls. So we need to pass this whole path to check is this binary exist or not. So let's call the access function. So let's call the access function like this. So here access of path, and what also they said, yep, if, okay, I don't remember access. So here is the flag, I guess. Alright, so let's see. Alright, good. Now it return either 0 or -1. So I'm going to make the return access take the value of the return value, return access, like this. And let's say if the return access equal to 0, then just return the path and break please. And here in the else we will just return null, which means that we didn't find the path that have this executable in it. So let's go back in the main.c and let's print the path. printf %s new line and the path. make good. For example, the path doesn't exist, nothing. Alright, so for example, grep-a grep doesn't exist, but the real grep exists. For example, let's say cut exists, so everything is good. Let's continue. Now we need to call the Execve. Alright, so now we'll run the Execve. To execute the command execve, it takes first the path, then the cmd, then the envp, the environment variables. So here p-error if there is something, if there is a problem, because if the Execve work well, it will not even reach this p-error, because as we said, Execve is replaced the whole process with a new process, so this p-error is not going to be also even printed. Alright, so let's say Execve here. Alright, and let's say what that's it, and we need to close, I guess, the fd of index 1. Like this. So make, for example, let's say nice, it's working very well. As we can see, it's working guys, as we can see. For example, let's say nvim, for example nvim in file, for example we have hello, for example, and here segfault, and we run the command, and we did grep-a to give us the output. Alright, so now everything is good. Now what we have left is to go to the parent process and continue and like get the output or read the output from the fd of index 0, then execute it. So first I'm just going to try to like alright, so now we are in the second phase. As I said, now we execute the first command and we have the output, we pass the output to the pipe fd of index 1. Then we need to execute the second command and pass the output to the out file. Alright, so first I need to close what? I need to close the pipe fd of index, I guess index 1, because I don't read it. Then here what I need to do, I need to make a dup, so dup2. I need to make the pipe fd of index 0. I need to make the std endpoint to this pipe fd of index 0. Then that's it. I'm going to execute this command, so I'm going just to do the same thing right here. Alright, and paste it right here. Alright, good. Then what I need to do, I need to open, so I need to open. Alright, so here after this Execve, everything is going to be stopped in this process, so I need to open this file before this Execve be executed. Alright, so what I need to do, I need here before this, I need to do fd equal open av of index 4. Alright, then here we need read only, no, write only, just write only, and here create like this, and here the permission 0660644. Alright, like this. Then just a simple if condition, if fd is less than 0, then just we are going to do p-error and open like this. Alright, that's it. Then I'm going to do another pipe, so here making the std out point where the fd of the out file points to. Alright, this simple way. Then we're going to do dup2 and fd, and the one is going to point to the fd. Alright, so this way And I guess that's it. Here I need to close the pipe fd of index 0, and that's it. And here I need to wait, so this process need to wait. So let's read for the wait function. Here we have the wait function. So all of these system calls used to wait for the state changes in a child of the calling process and obtain information about it. So simply this wait function, it will make the process, the parent process wait until this child process either exit, or like just when the child process finish, then we will go to this parent process and its code is going to be executed. All right, so here I'm going to do wait and just here now. All right, and I guess that's it. Let's run make. Alright, let's copy this and nvim. Alright, write read only, and where I have two pipes, pipe, yep, here, and that's it, I guess. Wait, yep, I need to include this dash wait in the header file. So here I'm going to do include sys/wait.h. so make no such file or directory. What? And here, for example, wt-l. Alright, let's see nvim main.c. So here, first of all, we make the dup2 dup1 points. Alright, so here dup1, remove this part. Alright. Second open. So we have the problem in the second option 0 1 2 3 4. Sorry. So the out file should be created. So if we don't have this out file, it should be created, guys. Alright, so I guess the problem in here in yep, here I need to do like this, or make got out file. Good, but the second command didn't get executed, bro. Yep, because here I need to pass the AV of index 3, guys. Sorry, here the AV of index 3. So make and cut out file. Good. So if we remove this out file like this, like rm out file, and we did again and cut out file, will have the same thing, and it will have like the same thing, like they say out file 2 cut out file 2. So it's have the same behavior as you can see, guys. So now, guys, the basic behavior of this shell pipe, it's been done. Now just we are going to do some test cases to test our program. All right, so for example, as we can see, if we did something like this, like we passed, for example, here, I don't know, ls-l, it's going to work. Yep, good. But if I passed like the path of this ls-l, so /user/bin/ls, it's not going to work. But in the real pipe it should work. For example, here ls let's say /user/bin/ls, it should work normally. Alright, so we need to to handle also this case. So to handle this case, I just need to add an if condition. So before going inside this sketch part, we need to do an if condition here. So if the cmd of index 0 is equal to dot to slash, for example, or let's say and cmd of index 0 and here also of index 0 is equal to dot and cmd of index 0 of index 1 equal to this slash, which means that we have already the path. So what we need to do, just the path will equal cmd of index 0. Alright, but else then we need to call this function. Alright, so we need to call this function right here, as we can see. Good, now let's do this if condition, and let's do it also right here, good. Alright, good, let's do it again, make. Alright, it's still not working, but in the real command it's working. Alright. Execve bad address. Alright. So if cmd of index 0 equal this, or let's say here, or now it's working. Yep, here I just messed up. So here I just messed up. I need to do or instead of and. So here also I need to do or like this. Alright, and let's do clear, make again, run. For example here, let's say we will have slash user slash bin slash this cut out file. It should work correctly. Alright, so let's say for example we don't have the first command, so what should happen? Let's say here nothing, but in the real command, if there is no command, you should see a problem, I guess. Right, nothing. But what is inside the cut out file 2? 4. Why 4? Okay, so I'm going to raise a problem. So we need to have the command here. So here in this case, what I need to do, if the cmd of index 0, right? Alright. So here I'm going to go to the main, to the utils.c, and in the get path I'm going to do an if condition. So if the path or the cmd equal null, then I'm going to return null. Alright, so here this is the utils, I guess. No, so I need the main.c. So here if the path is equal to null, so if the path, alright, is equal to null, alright, so let's see what's happening. For example, if the path is wrong, so for example let's say make slash user slash alright, not such file or directory, but I should handle this. Alright, so here let's say if the path equal to null, then I'm going to do printf we cannot find this command, and percentage s like this. Alright, so that's it. Okay, and here return -1. Okay, bro, for example, no, this is not the case, bro. What? Okay. So now we are going to compile and we are going to run here. As you can see, there is no problem. And for example, let's say we have a wrong command. For example, let's say wrong. Here I need to like have a specified message for this thing. So for example, in here in the nvmain.c, if the command is wrong, so what I need to do, let's go inside the utils.c. So as we said here, if the get path, if like okay, alright, so here if the flag is equal to 1, which means we found no, here where we check if the return axis is equal to 0 or not, else will return null. Okay, so what we will do, if let's say here in the nvmain.c, for example, I'm going to add an if condition. So if the path is equal to null, then what I need to do, I need to printf and let's say something like this, and the cmd of index 0 does not equal null. Alright, then we are going to do printf percentage s cannot this command, new line, cmd of index 0 like this, and return -1. Else if he entered an empty command, then we are going to do printf cannot find this command. Sad face. Like this. Nope, said bruh, come on, like this. And here also like this, bruh. Alright, good. Now let's continue, and I guess that's it. And here also I need to do return -1. So make Yep, I have a problem here. Semicolon. What? Why? Bro. The std out. So here, in order to print, I need to make this dup2, like call this function, which is dup2 equal std out. And here also. Alright, so make. Alright, good. Let's remove this new line and make it right here. And here also. Good, make. Alright, wrong, cannot find this command. For example, if we had a bad address, so for example, user cannot find this command. For example, let's say if we had slash execve no such file or directory. Alright. Alright. Good, good, good. Now I'm going to copy this. Let's remove the spaces, copy this and paste it also right here. Alright, like this. Alright, good. Good. For example, here we have a good command, for example ls-l, and here I have a bad command, for example segfault. Command not found. Alright. Alright. Why? Why it's happened? If the path is equal to null, why? It should print here like the name of the command. Why it didn't did like this? So here in this case, if we had the wrong command here, but in the second command it just print without the name of the command. Alright, cannot find this command. Alright, so let's see cmd av of index 2, bro, of index 3. Yep, index 3, guys. So make. Good. No, this is good. Alright, cannot find this command. Let's add 2 points here and 2 points here. Alright, good. Let's do make. Alright, for example, we have a problem here also. Alright. For example, here is good. For example, here is segfault. Why? Why, bro? You know what? I'm going to index first command, and here also I'm going to index this to say first command, and here I'm going to say second command. Alright, let's do it. So here it's from the first command. Alright, so I guess here it should be to have like 2. For example, if you had e, why it like is giving me like this empty message? It should print the name of the wrong command. So let's see why. Here I said if the path null and cmd of index 0 does not equal null. Like this. What? Why? Bruh, come on. So here, if the path of index 0 equals this, else path equals cmd, and if path is equal to null and end. Alright, let's see why. Let's do gdb output, sorry, break at the main, lay in, set fork mode, set follow fork mode child. Alright, let's continue. Good. P pass. Why? Why it's equal to WC? Why? Why WC, guys? What the fuck? So let's run again in file. For example, hello, like this. Then again, segfault here, out file. Yes, set follow fork mode child, print hello. Alright, good. Print cmd segfault, good. Print path null, good. But what is the problem? Yes, like, wait. Here we are taking, bruh, I switched them, bro. Here the AV of index 2. Come on, guys. Like this. So here we have segfault. For example, if the first comment is empty. Alright. Why it doesn't print nothing? Alright, let's do this case. Show gdb output, break at the main, lay in, okay, run in file, cmd, and out file. Right, let's follow fork mode child. Print cmd of index 0 equal to null, good. What, bro? Again, in file, run in file, cmd out. Okay, let's continue. Let's print cmd of index 0 equal to null. Why? Why segfault? Why segfault? Why segfault, guys? Alright, you know what? I'm going to add the if condition in the utils.c. So in the if split, I'm going to add if if str or separator equal to null, then please just return null. Then in vim main.c, I'm going to remove this else if condition like this. Alright, and I'm going to go up here, if cmd equal to null, then just I'm going to printf, and we cannot find this command, which is empty one, then set face, then new line, then return -1 like this. So make, alright, so let's go to the utils.c and vim utils.c, and here I had a problem. Yep, I need to compare it with just null terminator, not the null pointer. So make, why gdb output? Yep, I guess I understand why, because here I need to make a redirection, like I need to make, sorry, in the nvim, in the main.c, I need to make a redirection, like I need to make this acd out, the one point to the acd out, so I need to make it also right here. Alright, and also let's do make, alright, it's not working. So gdb break the main, lay in, run in file, empty command, cmd out, set follow fork mode child, continue, print cmd, why it's not equal to 1, print av of index 2. Alright, let's run again in file, and here empty command, and here we have cmd, and here we have out file, and let's see what happened in the split. Alright, let's go. Okay, let's see split. We have here print str equal to null. Bruh, I am fucking stupid. And vim here I need to make the same thing, like and here the same thing. Alright, let's read the gdb break the main, lay in file, out file, set follow child. What? Alright, so you know what, I'm going to hardcode it. So just if like this, or you know what, here I'm going just to make it equal to 0 or not. Okay, 0 gdb break the main, lay in, run in file like this, cmd2 out file. Bro, I need to again set run info, or you know what, I guess I have the correction. I am going to do just if scr of index 0 equal to 0, make finally, guys. Alright, so let's do the same thing for this second command. Sorry, nvim main.c. let's do the same thing. So like this, and I'm going to copy it right here, and I'm going to remove this part. Alright, so like this we have our command, as you can see. Okay, if there is a problem also the second one or the first one is good. For example, ls, the second one should raise an error. Alright, why? Alright, for example, first is good, second is wrong. Alright, we have a problem with the second. So let's debug this second thing. Or here I need just to add or like this. No, sorry, not here. What? And here and here is the same command. So if cmd of index 0 equal like this. Okay, if the path is equal to null, let's remove this. Alright, let's see. We have a problem here. AV of index 3 is good. Alright, we cannot find dup2 saved std out. Yep, here I need to make again this dup, because here when I assign this saved std out to the dup1, it is just local to this process, but I need to redo it right here. Alright, if I want a copy of the std out, so if I did make good, as you can see everything is good. For example, let's say here is empty, good. For example, let's say here it's good, or it's empty, and here for example let's say it's good. Alright, now let's do some real command. For example, here we're going to do ls-l wc-l out file. The out file is good, as you can see. Let's remove out file to remove its all content. Okay, for example, the in file, it will have, for example, some big data like this. And I will say, for example, grep L, for example, and cut out file. Good. Now I'm going to make the real command. So for example, here grep L, and let's see what is inside the cut out file. 2 is the same output, as we can see, guys. So this is our code. As we can see, I explained to you guys what is a process, what is pipe, what is the dup2, and we try to implement this beautiful shell pipeline. So I just hope you enjoyed this video, and see you in the next video. Peace.